Hi everyone, I'm Edward and I'm a solutions architect here at Striim. Thanks for joining us in this tutorial of how to migrate your on-premises or other cloud MySQL database to GCP Cloud SQL for MySQL with zero downtime. Now this tutorial makes some assumptions in that you've already deployed Striim through the GCP marketplace, installed the MySQL JDBC driver on the Striim server running in GCP. Please reference our documentation at docs.striim.com to see how to do this. Have a source MySQL database configured with a user with read and replication privileges. Again, please reference our documentation. And a Cloud SQL for MySQL target database configured. Additionally, this is a great time to think about networking. You'll need to be able to connect from Striim to both your source and target databases. We suggest to reach out to your GCP contacts to configure a cloud interconnect or a VPN so that you can connect with private IPs. An online database migration consists of two processes: an initial load process to capture a snapshot of your database at a single point in time, and a log-based change data capture process to continuously capture all of the inserts, updates, and deletes that occur on your source database while the initial load is propagating. Striim helps to coordinate these two processes. And during this guide, we'll first build and test an initial load application, then a CDC application, and finally we'll execute an end-to-end database migration, including schema migration. With that said, let's dive in. So here we are at Striim's UI. So all I did was deployed Striim through the GCP marketplace and pulled up Striim's web UI. So let's go ahead and log in. The default username is admin, and then depending on how you deployed Striim, if you deployed a metered solution, the admin password will be in the GCP deployment window. So we'll go ahead and log in. So here we get to Striim's homepage. And here you have three different panes. On the left-hand side is the dashboarding piece. So along with moving data in real time, you can also visualize it. Customers will typically use these dashboards for things like data validation and verification. And all of these dashboards are created with drag and drop widgets and then populated with simple SQL queries. In the middle, we have the applications pane, which is the main pane that we'll be dealing with today. And what we call applications are all of your individual data pipelines or data flows from a source to a target. And lastly, there's source preview. So you can preview your data before moving it. So if we go ahead and click on this applications pane, you can see that we have a variety of applications loaded, but we'll go ahead and click this blue Add App button in the upper right-hand corner to create a new application. And here you have a few options. On the left-hand side, you can create an application with wizard-based development. Just enter your various configuration properties and Striim will create the application for you. You can start from scratch to use our typical drag and drop UI, which is what we'll focus on today. Or you can import an existing app. So all of the applications in the UI are backed by what we call a TQL file, which essentially looks like PL SQL. So here you can actually programmatically create applications. And then additionally, there's a REST API around Striim where you can create more of a managed service around Striim. But today we'll focus and just click Start from Scratch. So here let's go ahead and give the application a name. We'll choose MySQL to Cloud SQL init load. And then here you can also choose a namespace. So namespaces are logical groupings of applications where you can create more of a microservices approach with a certain application that reads from a source and one application that writes to a target. However, in this case, we'll just choose the default admin. Go ahead and click Save. And now here we are at the default Flow Designer. So this is primarily where you'll be interacting with Striim and creating all of your Striim applications. So go ahead and go over into the Sources pane in this left-hand menu bar and drag and drop a database reader component. So the database reader component is used for the initial load application, and it captures a snapshot of your database at a single point in time. So go ahead and give this source a name. We'll call it MySQL init load source, and provide a JDBC connection URL. An easy way to do this is you can just hover over this tooltip, copy and paste the MySQL JDBC connection URL, and enter all of your various connection properties. In this case, I've already built my JDBC connection URL, so I'll just go off screen and go ahead and copy and paste that. So here you can use a private IP if you have the proper networking set up. Then provide a username and password that has read privileges for this database. Go ahead and click on this blue Show Optional Properties to expose some additional properties. In the Tables property, this is where you specify the tables that you want Striim to read from. In this case, we want to read all of the tables in the employees database. So we'll select employees.% to capture all of them. But you can also specify individual tables in the syntax schema name, period table name. Additionally, in this query property, you can run any standard SQL query that you'd like on your source to do the initial load, if you'd prefer to do that, versus specifying it in the tables property. The last thing that we'll modify here, it's the fetch size. So this is important when you're dealing with large data sets. Here we'll just set it to 1,000. The last thing that I'll mention is this quiesce on initial load completion toggle. So here you can specify for the Striim application to automatically stop once the initial load is completed. And this is really helpful when you're coordinating the initial load in CDC processes. But for now, since we're just doing a demo test, we'll go ahead and leave that blank. Now, let's give the output name a Striim. So we'll select MySQL init load source and just append _Striim to the end of that, and save this component. So before we continue, I want to ensure that this application works. So in order to test this, go up into the top middle of your page and click on this gray Created button. Go ahead and click on Deploy App and select the default configuration. So just press the blue Deploy button. Then before starting the application, click on the Striim component. So that's the circle with a wave icon right here underneath the database reader. And click the I button directly to the right of it to bring up the preview window. Now go back up to the top middle of your page, click that Deploy button, and click on Start App. So now you can see that Striim has successfully read our source database, and we're pulling in both the various fields as well as the associated metadata. So now that we've confirmed that we can successfully read from the source database, we can continue. Throughout your application development, it's extremely important to test each individual piece before continuing. So if anything went wrong here, then we would know that there's an issue with connecting to your source database. Maybe it's an incorrect JDBC connection URL, maybe incorrect tables property, or whatever else. An additional way to monitor before we add in the database writer target is to click on the See Application Progress window in the upper right-hand corner, so you can see the overall progress of your initial load. In this case, because we don't have any target, the output is not applicable, but you can see that we've successfully read all of our source tables. And then it also gives a breakdown of the associated tables, so you can ensure that for each table, you've successfully completed the initial load. So now that we're happy that the source works, we'll go ahead and add the target. So in order to do so, just click this running button, click Stop App, click Stopped, and click Undeploy App. Again, click the Striim component, so that's a circle with a wave icon, and click the plus button directly to the right of it. Click on Connect Next Target component to connect your target, and give this target a name. We'll say Cloud SQL for MySQL init load target, and then select an adapter. Here, choose the database writer, so just start typing database and select database writer. Again, the properties are very similar to the database reader component, so specify a JDBC connection URL of your target Cloud SQL for MySQL database. So we'll go ahead and again copy and paste that from off screen. An important thing to note here is that for MySQL, appending this rewrite batch statements equals true to the end of your target JDBC connection URL will greatly increase initial load performance. Again, provide a username as well as a password for a user that has write privileges to your target Cloud SQL instance, and then specify the tables that you want to migrate. So in this case, we want to migrate all of the tables within the employee's schema. And here the syntax is source target pairs. So we'll select employees.% as our source, comma employees.% to our target. Again, here you can specify individual tables in the syntax source schema name, period source table name, comma target schema name, period target table name. Go ahead and click on Show Optional Properties to expose some additional properties. And here, the main things to note would be the batch policy and commit policy. So underneath the covers, Striim creates micro batches of your events because it's much more performant to apply 1,000 events at one time rather than insert ID 1, insert ID 2. So here, depending on your data size, you may want to change these. So the syntax here means event count 1,000, interval 60, whichever happens first. So if you're dealing with a really small source table that has less than 1,000 records, then Striim will wait for 60 seconds before applying the data to your target. So if you have small source data, you may want to decrease this batch policy and commit policy. In this case, we have a decent amount of data, so we'll increase that to event count 10,000 and commit policy event count 10,000. Another property to note here is this parallel threads property. So underneath the covers, Striim parallelizes the initial load to ensure that it completes faster. So here, in this case, we're running Striim on an 8-core VM, so we'll select 8. But for initial loads, typically customers will deploy a larger Striim VM, say 16 or even 32 cores, to complete the initial load as fast as possible. And then for their CDC process, you can decrease that down to say 4 or 8 cores. In this case, we don't have that much data, so we'll select 8 in that parallel threads property. Then we'll go ahead and click Save. Then we'll go through the exact same process to go ahead and deploy and run this application to make sure that our initial load works. So we'll go up here to the blue or the gray created button. Go ahead and click Deploy App. Click that blue default deploy button. Go ahead and click the Striim component. Click the blue preview on run button. Go back up to deployed and click start app. And now you can see that the Striim application is starting, and we're successfully reading all of our source data as well as the associated metadata. One thing that I haven't mentioned yet is that it's extremely important for the initial load to have all of your foreign keys turned off on your target database. So unlike CDC processes, where Striim replicates all of the data in the order that it occurred on the source database, with the initial load, there's no way to ensure that, for example, a child record was written before a parent record within a foreign key. So here, that's why you just turn it off for the initial load and then turn it back on afterwards. In this test, we're just testing with some simple sample data, so we don't have to worry about that. And that's what I would highly suggest for you to do as well. So again, let's go ahead and go up here to click the See Application Progress window to see where Striim is within the initial load. So it looks like so far we've read about 2.2 million out of the total of almost 4 million records in our source, and we've output about 2.4 million to our various tables. So here you can see the overall table breakdown, and we'll go ahead and click OK. While we give this a moment to continue, we can just go ahead and go to our target Cloud SQL for MySQL instance. All I did is I went to the Cloud shell and connected to our target Cloud SQL for MySQL database, and we can run a simple select count star from one of our tables to ensure that data is landing successfully. And all 3 million rows of that employees table has successfully landed. So now we can see that our initial load has successfully completed, so we can move on to our CDC application. So we can just go ahead and keep this application running actually, and go back up here to the upper left-hand corner menu bar and click on Apps to get back to the main applications page. Again, click the blue Add App button to add an additional application. And again, we'll go ahead and click the Start from Scratch to create our CDC application. In this case, we'll name it MySQL to Cloud SQL MySQL CDC. Again, use the default admin namespace. Go ahead and click Save. Here, we're in our Flow Designer again, and the main difference for this application is we're going to go ahead and scroll down and locate the MySQL CDC adapter, which we'll use instead of using the database reader. So what the MySQL CDC adapter does is it reads from the underlying MySQL bin logs to continuously capture all of the inserts, updates, and deletes that are happening while that initial load is being propagated. Again, give this adapter a name. We'll say MySQL CDC source, and provide a JDBC connection URL of your source MySQL database. Again, we'll just go off screen quickly to copy and paste our MySQL JDBC connection URL. Provide a username and password that has both read as well as replication privileges. And one thing that I didn't mention earlier is that you can use this test connection button to easily see if Striim can successfully connect to your source database. We'll go ahead and click test connection, and you can see that we can successfully connect to our source database. Again, we'll specify tables to read from. Here you can specify schema name, period table name. In this case, we have an orders table that we'll use. So we'll select Striim.orders just because we have a data generator for this table, so we can easily see all of the inserts, updates, and deletes come across. If you click on Show Optional Properties, you can see some properties that we'll dive into later, primarily around the start timestamp value. So in order to synchronize the initial load and CDC process, you first capture a start timestamp to ensure that the stream application starts from that start point and that we don't lose any data. In this case, we're all good with that. So then we'll just go ahead and provide the stream name. Again, we'll copy and paste the source, append underscore stream to the end of that, and click Save. So now let's go ahead and test that this application successfully works. So let's go ahead and go back up to the top middle of the page. Click that Created button and click Deploy App. Again, use the default deployment topology. Click Deploy. Click on the wave icon, so the stream component. Click on that I button, and then start your stream application. So here you may notice that you don't see any data flowing through. So by default, Striim only looks for the new inserts, updates, and deletes that are occurring on your source database when you use a CDC component. So if you don't have an active database, you won't actually see any data flowing through. In this case, we have a data generator that I'll go ahead and start. So now you can see that there's data flowing through Striim. And again, we capture all those fields from the orders table that we're now reading from, as well as the associated metadata. And when you're building more complicated streaming analytics applications, this preview window can also be incredibly helpful to ensure that your data is in the right format at each step of your pipeline. So now that we've tested that we can successfully read via CDC from your source MySQL database, let's go through the same process to connect a target. So we'll go ahead and stop the stream application, click Undeploy, click that stream icon, click the plus button next to it to connect your next target component. Go ahead and click on Connect Next Target Component. Provide this target a name. We'll say MySQL, Cloud SQL, MySQL, CDC target. Again, select the database writer adapter, and then provide all of your connection properties. So here you can just copy and paste from your initial load application. So we'll go ahead and specify our connection URL, username, as well as a password. Here, instead of using wildcards, which we used for the initial load application, since we only have a single table for that data generator, we'll just specify that single table. So we'll say stream.orders, stream.orders to migrate that single orders table. Again, you can click on Show Optional Properties to expose additional properties, but in this case, we'll leave them all the same. Go ahead and click Save to save your CDC application, and go through the same process to test to ensure that this properly works. So go back up to the Created button, click Deploy App, click the blue Deploy button, go ahead and click on the stream icon, click the I, and then go back and click on Start App. So again, you can see that the stream application is running, and we're picking up new changes on our source database. So these are all those fields from that orders table. We can go back up here to the See Application Progress to see the overall progress of our application. Here you can see that we've read about 300 rows. And as I mentioned earlier, the default batch policy and commit policies are event count 1000, interval 60, whichever happens first. So in this case, we've only read 540 records, so we haven't output anything to the target yet. So here, let's just go ahead and give it a minute to generate enough data for us to output to the target. Now you can see that Striim is outputting to the target. And if we go to our target Cloud SQL for MySQL instance and just run a simple select star from our database, you can see that all of her data has successfully landed on our target database. So if we go back into Striim, before we execute the end-to-end migration, I'd like to quickly show some of the additional monitoring pieces that you can use. So go ahead and go up here into the upper right-hand configuration wheel and click on Monitor. So this gives an overall view of your Striim application. So you can dive into each individual piece to ensure that everything is running smoothly. So you can take a look at your sources. You can see that we've read almost 2,000 records from our source database now, and you could dive into more details if you'd like. If you had any queries, any SQL queries run on the data as it flows through, you could take a look at things like query performance. But in this case, we'll go ahead and click on targets. You can ensure that the amount of events in equal the amount of events out. And then you can also dive into more interesting monitoring aspects, such as end-to-end lag. So how long does it take from Striim reading a record to when it outputs to the target? As well as dive into more details to really get a good sense of what's going on your target. And as well as things like operation breakdown, so you can see that this is a relatively insert-heavy load. All of these metrics are accessible via a REST API, so typically our customers will integrate them into existing monitoring applications. So if we go ahead and click OK, now that we've executed both the initial load and CDC processes separately, we'll go ahead and go through the whole end-to-end migration along with doing the schema migration. So let's dive in. So before executing your database migration, first you need to migrate your schema. This can be done using native tools such as MySQL dump and be done on your own, or we also have a schema conversion utility that's built into the Striim product. So all I've done here is I've SSH'd into the underlying VM that Striim is running on. In the GCP console, there's that easy SSH button, which allows you to easily SSH into the underlying VM. So here I'm just going to run our schema conversion utility to migrate our employees schema. So first, I'll change directories to Striim's main directory. That's just /opt/Striim. And then I've actually already built my string that I'm going to run. So here we're just calling out to our schema conversion utility. Then you provide the source type. In this case, we're using a MySQL source database, the JDBC connection URL, a username and password that has read privileges on your source database, the tables that you'd like to read from. So this is the same tables property that you were seeing in the UI earlier, as well as the target database type. So we'll go ahead and run this script. Now you can see that Striim connected to your source database. We found 6 fully compatible tables. And then if you were doing something like a heterogeneous migration, there may be some tables that wouldn't be compatible, say specific user-defined data types, and others that would be representative in these other SQL files. So now what this script does is it executes and creates a whole bunch of SQL files in this directory. So let's go to that directory, do a quick ls, and then let's take a look at our conversion report to see how successful our schema migration was. So you can see that we were going from MySQL to MySQL. All of our tables were successfully converted. And then you can dive into the tables that were converted, as well as the foreign keys. So as I mentioned earlier, the schema conversion utility creates two scripts, one which applies all of the tables, and then a separate script for you to apply the foreign keys after the initial load is done. So all we're going to do here is we're going to take that converted tables.sql file, apply it to our target Cloud SQL for MySQL instance. We found just that the simple upload button within Cloud SQL for MySQL is very helpful, or you can use, say, MySQL Workbench or any other utility. So now that we've migrated our schema, we can continue with a whole end-to-end migration. So what I'm going to do is we're back in Striim, and I'll go ahead and stop and undeploy our initial load application to edit it, and you can point it to, say, either a different database or maybe different tables that you want to migrate for your initial load. For production use cases, we've found that 10,000 as the fetch size is a good baseline. And we'll go ahead and toggle that quiesce on initial load completion, just so we can easily see when the initial load is completed. We'll go ahead and click Save. And then we'll go to our target database writer. Again, edit this as need me to change your tables property, or for example, write to a different Cloud SQL for MySQL database. And then we're going to increase our batch policy and commit policy to 100,000. And then if need be, you may want to increase this parallel threads number based off of your database or based off of the Striim VM size. We'll go ahead and click Save. And then before running the end-to-end migration, what we need is we need to go to our source MySQL database and execute a command to find the current timestamp. So we'll go ahead and we're just in MySQL Workbench. Go ahead and run select current timestamp, and then just copy and paste that for your use later. So now let's go ahead and go to our CDC application to edit it for our production use case. So what you're going to do here is you're going to, again, stop and undeploy this application. You're going to edit the MySQL reader to start from the start timestamp that you captured earlier. We'll go ahead and select that. Go ahead and click Save. Then another thing that we're going to change is we're going to go into our target database writer, change this as need be, click on Show Optional Properties, and add in the ignorable exception code of 1062, no op update, no op delete. So because there may be duplicate records that were already written by the initial load application, there may be errors that come back saying, hey, this error or this record was already written to your target Cloud SQL for MySQL instance. And even if that happens, we want the Striim application to continue writing. So we're going to go ahead and enter the duplicate primary key error for MySQL, no op update, no op delete. Then we'll go ahead and save this application. And the other two things that we want to do is go ahead and go back up to this exceptions button right here. Click on that and click turn on. So what this does is this turns on Striim's exception store and captures any events that we ignored from that 1062 no op update, no op delete, and you can always read from them later. So this is um, an optional step, but is helpful if to ensure it really just gives you a better idea of what those events were that weren't written out to your target. Lastly, we're going to turn on recovery by going into the app settings. We'll enable data validation and turn on recovery. And so this just ensures that even if the Striim application stops for some reason, Striim captures checkpoints of your last known good written checkpoint and your last known good read checkpoint and correlates the two to ensure exactly what's processing. So then we'll go ahead and click Save. So now all you need to do is start your initial load application, wait for it to complete. The quiesce state will come up in the top middle of the page, and then start your CDC application. And because we're starting from the start timestamp, that will ensure that we capture all of those events that occurred throughout the initial load. So here we just showed you how to do an online database migration with Striim from an on-premises or other cloud MySQL database to Cloud SQL for MySQL. So please reach out to a Striim technologist to learn more, or reach out if you ever have any questions. Thanks for watching. Bye.